everybody. I'm Elspeth. I'm from the University of Manchester, and yeah, I'm going to talk to you about some microvertebrates. So, before we start, just to clarify, microvertebrate in this sense is anything that's smaller than a dinosaur, basically. Just to keep it nice and simple. I think the biggest thing that I worked on was about 15 centimetres, something like that. Cool. So, what is the Hell Creek? Well, the Hell Creek is predominantly a fluvial system in kind of the Great Plains area of North America. So if you think around South Dakota, Montana, somewhere around there. And it basically covers the last period that we saw the dinosaurs. It's been described for just over 100 years now, and it was described by this chap here in the Fantastic Hat, who is also the first person to describe T-Rex, just a bit of fun fact. And yeah, so it's one of the most prolific vertebrate localities in North America. So where is it? This is a map of what America looked like during the late restrictions. So as you can see, you've got the retreating interior seaway there, and the area of the Hell Creek is kind of around here, and I work just here. Oh, I can do it on here. Oh, cool. So this is what we're looking at when we zoom in. This is a geological map of the region, and everything in red is the Hell Creek. Well, I say that. It's the Hell Creek in South Dakota, North Dakota, and Montana, but as soon as you move across into Wyoming, it's called the Lance Formation for some unknown reason. So, my key problems that I wanted to look at is, what is the fauna that we have in the Hell Creek? Is it just dinosaurs, like quite a lot of the papers saying? How is it preserved? So what kind of things are we getting preserved and how well? And what does an actual realistic reconstruction of this fauna look like? Because when you type Hell Creek into Google, this is the kind of thing that you get. And again, just to reiterate, why does this matter? Well, this is one of the most recent works of Paleoecology that's been done in the region, and as you can see, it's a lot of nice dinosaurs. But paleoecology of a formation overall is so much more than just one specific group of creatures. If you take aside the dinosaurs, there's so many other things, like the mammals, the lizards, birds, etc., etc., etc. There's so much we could be looking at to get an overall broad picture of what was going on in this formation. So, just to give you an idea of what these look like when they're fossilised, this is what we've got. So, I went to the AMNH in America, obviously, and I went through their collections, and this is what I found. So, 4 species of mammals, some birds, lizards, 3 species of crocodile, and 4 species of amphibians. So if we focus down a little bit more on that, oh, no, sorry, I'm going to talk to you about taphonomy first. So for those of you in the room that don't work on taphonomy, I'm sure it's a bit of a kind of scary prospect. So it's basically the processes between an organism dying and its recovery. But as I think Emma was saying earlier, there's lots of things in there that can like sieve out some of the material. So either it's not found or it's broken up and completely lost and things like that. So one of the things that I had to think about in my study was about taphonomic modes. It's all well and good that we've got these fossils from the formation, but the formation is hundreds of kilometres wide. So if they're not from the same area, have they been preserved in the same way? Like, for example, these pachycephalosaurs living on a nice mountaintop environment with very little sedimentary deposition. They're not going to be preserved very easily, but at least they're in the same environment. Whereas down here, we've got a nice sea environment. There's going to be lots more deposition. Things have got hard shells. They're going to be covered. They're going to be preserved. They're very different modes, though. You're obviously not going to get them next to each other, but it's something to bear in mind that these are different environments that have them. So, with that in mind, looking at my field sites, as you can all see, they're about 1 kilometre away from each other. So, things being in a different taphonomic mode is not something that I really had to worry about. However, taphonomic grade was something that I needed to take into account because to to identify species, you don't really want them to be broken up. So taphonomic grade here, all I'm trying to show is how close the organism looks to its original before it was fossilized. So I called my grade 1 grade A in this study, and grade 4 was grade C. So focusing in on the actual groups, these were my mammals. So I managed to find 27 mammalian fossils in the whole of the AMH collection, so just to give you an idea about how rare they are. And as you can see, they're preserved as a variety of skeletal elements. And I managed to identify them down to 4 species, which I wasn't expecting to do, to be honest. I was expecting to not get that many. But what we found was that they were really well preserved. So as you can see in this slide, like for example, this here, that's Proton lambda, and the teeth are just absolutely phenomenal. You can tell more or less exactly what it is by looking at them. And yeah, so these fossils were predominantly preserved to a very high taphonomic grade, no lower than grade B, and the teeth were the best preserved element, probably something to do with the enamel that's on the teeth that stops them from being broken down by those fluvial processes. So amphibia were much, much more common, and especially the vertebrae, 87, it was kind of ridiculous. Kind of wanted a bit of variety in there, but there wasn't any. So yeah, I managed to identify down to some species. And these were all, again, they were quite well preserved, grade B, but there were some much less well preserved ones. There. And then Squamata. So this is Palaeoecological Reconstruction, one of my favourite fossils from the Hell Creek. He is kind of like, if you think about the Komodo dragon, he's about that big. So he was a threat to the dinosaurs, I'd like to think. And he was very easy to identify, mainly because he's so big. As I put there, I could identify that there were pleiads, varanids, and geckos, but they're just tiny, so you can't get any lower than that because everything's been broken off and they're preserved to a much lower taphonomic grade. So what I found, it was quite weird with the squamates, was that if you've got fewer skeletal elements in your group, they're normally preserved to a higher taphonomic grade. And I think that might just be because I can't identify things if they've been broken up, so I couldn't physically put them in that group. So finally, the birds. Yeah, no identifications could be made there because they all kind of look like this, just sort of fragments that are completely broken up. However, the toe bones, the little phalanges, they were really sweet and yeah, very easy to identify because of their shape, and in some cases they were broken up, so you could see that they were hollow inside and therefore probably a bird, but still we couldn't identify anything, so it was mainly taphonomic grade C that they were preserved to. So bringing back that graph of the dinosaurs, when you put in my data, that just from the species that I've seen in the Hell Creek, this is what you get. As you can see, it's very varied and nice and colourful and lovely. And then when you put that together with everything, this is what you get. And again, as you can see, there's so much more to this ecology than just the dinosaurs here. Or, sorry, they're not Sauriscia nor the Fisher anymore, are they? Sauria. So yeah, it's a fantastic ecosystem and there's so much going on there. And it's something that needs to be noted, really. So finally, my Paleoecological Reconstruction. This is what we'd all think about when you think of a nice ecological pyramid. Nice wide base, lots of producers, fewer primary consumers. Up to the top, you've got far less of them. This is what mine look like. So as you can see, it's not really what you'd expect. My primary consumers down there, there's only 3 of them. So again, that's probably a factor of taphonomy, in that they just simply weren't preserved, all of the insects and things like that. We have got leaves in the Hell Creek, but we haven't got any like associated animals with those leaves, so you couldn't say for certain exactly what things have been eating. So, in summary, what do we have in the Hell Creek? We've got a fantastic ecosystem. It's so diverse, really rich, and it's something that needs to be documented more. The things that have been preserved, the mammals were preserved as teeth, the squamates and the amphibians as vertebrae, and the aves as bone fragments. So there's a bit of a difference going on there. Maybe it's something to do with the structure of the animal, or maybe it's something to do with the bones themselves. And overall, they were quite well preserved, but the birds especially were really bad. And the realistic reconstruction was not like the first picture that I showed you of the dinosaurs. It is a much more rich ecosystem, but it's a very skewed trophic structure. So thank you all for listening, and if you've got any questions, feel free to ask away.